Your Pandas code might be running 5, 10, or even 50 times slower than it should be, and you probably don't even know it. In this video, we are diving into Pandas performance optimizations, practical proven ways to make your data frames load faster, use less memory, and run computations in a fraction of the time. We will look at real before and after examples, measure the speed differences, and I will explain why these changes work. So let's look at our first example here, and this is a very basic use case where after some analysis or data aggregation, you save these data into a CSV files, which are very slow and take so much more memory. So let's just import our libraries here and load our data frame. This is just 100,000 rows with 5 features, and we will save this data frame into a CSV and read it back. Let's see how much time does it normally take. So it took like 684 milliseconds. And if we just replace this same thing to save it in a Parquet file, let's see how much time does it take then. And the same data frame took 103 milliseconds. So this is like almost 7 type improvement to your normal workflow. And if you don't need the data in human readable form, then you can always use Parquet files. Parquet files are specially designed to store data in binary format, and they also take less space on your disk. So I have saved this data frame into a Parquet file. Let's check their size on the disk. So this is the normal data CSV file that I have generated, and it took like 9.28 MB. And for the same data, the Parquet file took 4.83 MB. So it's like half. So you save like 50% of the space and also like 8 to 9 times of the time. At number 2, we have use of categorical data type. So let's load our data first into our data frame. So our data frame contains just one column with city, and this has like 10 million rows. All these 4 values are repeated, and together they make like 10 million rows. Categorical data type can be used on all the same columns where you use the object data type. And when you load this data directly into Pandas assign object data type to these string types. So let's look at the data type first. And as you can see, this city column is of type object. In this example, we will try to take a look at number of unique examples in this series. And it took like 563 milliseconds. Let's just convert into a categorical data type and run the same procedure again. And now it uses 50 milliseconds. And this works because categorical data type stores as numbers. So it does not just store these strings, it maintains a hash and use the integers for these values. So in this example, we have 4 different strings here: London, Paris, Tokyo, and New York. So let's just say London is 1, Paris is 2, Tokyo is 3, and New York is 4. So instead of maintaining a series with all these values in string format, it maintained a series with integer formats. So when you perform operations like unique or group by, then it becomes so much faster because Pandas is not comparing the strings. It is just using integers. At number 3, we have use of isIn method. So let's just say you have a data frame and you have a list of values that you want to check. Let's just load them, and we want to check the values in data frame column which are present in this particular list. So the normal way would be to write different conditions which satisfy in this list. So this list contain values between 100 and 120. So these are 20 values, and if you want to check for each value, then we need a single condition for each value. So this would be like data frame column equal to 100 or 101 or 102 and so on and so forth. And let's just run it first to see how much time does it take normally. So it took like 206 milliseconds. And if you use the isIn method, which is essentially doing the same thing, we are checking the data frame column if it is present in the values of our list. So let's just run it and see how much time does it take. So this took like 122 milliseconds, which is way faster than 206 milliseconds. And isIn is faster because it does everything in one pass. So let's just take a look at this one first. As you can see, there are 20 conditions here. And for each condition, Pandas maintains a Boolean array here. So for the first condition, it will make a Boolean array of true or false if this particular value is present in our list. And same goes for the second condition here, and third here, and for all these conditions. Essentially what happens is we are maintaining here 20 different Boolean arrays, and at the end we are combining them to get the result. And in this isIn method, we do all this in one pass. So that's why it saves all this time. At number 4, we have use of NumPy vectorized methods. So let's say you have a data frame with two columns and you just want to perform a simple operation of addition, subtraction, multiplication, or square root or any other method. And there are multiple ways of doing this thing. So one of the most common way would be to use the apply method, which takes all the values in a data frame or in a series and then apply a method to it. This is a very slow method because it's essentially like a for loop which takes all the values one by one and then perform the given operation. So we performed the operation on 1 million rows and it took like 9.06 seconds. Let's just do the same thing with NumPy vectorized operations. In Pandas series, you can directly apply NumPy vectorized functions. You don't have to mention these operations separately. And this took like 3.52 milliseconds. So this is a lot of improvement on this very slow .apply method. So if you are going to use this for very simple methods which are provided in NumPy, so instead of using .apply, you can directly use the NumPy functions here. At number 5, we have filter early and merge later. Let's just say you have two data frames and you want to combine them and filter some values. So what you could do is there are two ways of doing this thing. You can either merge first and then filter, or you can filter first and then merge. So let's just look at the first way in which we are going to merge first and then filter. So this took like 279 millisecond. Let's just filter first and then merge and see how much improvement does it make. So this took like 230 millisecond, which is not a lot of improvement over 279 millisecond. But if you're going to do some analysis on a runtime and you have to present these results to end user, then every millisecond count. At number 6, we have merge without sort. Let's just say we have two different data frame, left and right, and we want to merge them. So what happens is by default, if you don't mention here sort keyword, it will always sort. So pd.merge will always sort. And what happens if you run it? So first it will merge these two data frames, left and right. So this is the first step. And after we combine them on key, in the next step, we are going to sort them. So effectively what happens behind the scenes is if you just use merge method without sort parameter, then this is going to happen in two different steps. So it takes a little bit more time to perform the additional operation of sorting. And this took like almost 4 seconds. And let's just run it with sort equal to false. And if we merge it without sorting, this is just a little bit faster than the merge with sort. And that is it. Some of the most effective ways to make pandas run faster and use less memory. We have seen how changing data types, using efficient file formats, smart filtering and avoiding unnecessary work can make a huge difference. Remember, small changes in how you write pandas code can have big performance impacts, especially with large datasets. If you found these tips useful, hit that like button so I know to make more performance focused content, and share this with someone whose pandas scripts could use a speed boost. Thanks for watching and happy data wrangling.